Okay, so today we will go into session chapter 6, application of definite integral. Okay, so actually right now we already know what indefinite integral is, and also definite integral, right? Definite integral, we should have a limit for the integral from a to b. Definite integral. For indefinite integral, we don't have a and b, so that finally we can get a function plus c, right? But chapter 6, we will focus on the applications of definite integral. So that means we will be talking about some calculation, and finally we can have some number. Actually, we already learned this part a little bit in chapter 5. For example, we just use definite integral to calculate the area, right? Area between two curves, right? In chapter 5, already learned it. But this time, we have more applications for definite integrals in chapter 6. And you for the following sessions, you can find that we always apply the Riemann sum to get the finite sum. Then we take the limit to get the final value. So for the first part, we were talking about the volumes using cross-section. The idea is very intuitive. For example, if there is a 3D object, if this is x, this is y, and this is z, then maybe there is a solid, for example, just like this. We want to get its volume, because it is not that regular as like a circle for ball, right? If I give you a half circle, you can get the ball. But actually, this curve is not that regular like a circle. So we cannot just follow the formula to get the volume. We definitely need to use the definite integral to get the volume. Okay, so the first idea is about using cross-section to get the final volume. So what is a cross-section? Cross-section means like this. Like this. When you just use a plane to cut, right? For example, you just use a plane to cut, then you can get the cross-section. So the idea is, if each cross-section, you can just use the plane to cut, then you can get the area. Use the cross-section times delta x, then you can get the volume for this small piece, right? And you can just accumulate one by one, then finally you can get all the volume. Okay, so actually we just extend the Riemann sum to a 3D object. In the past, maybe we just apply Riemann sum to a 2D area, right? For 2D area, we also do the same thing, but the difference is for in the past, we just face a 2D problem. Y is equal to f of x, so that from A to B, then we can just divide it many pieces. Then we can get the rectangle by using one of the point in the subsection, then we can get the f of ck, right? And then times delta sk. Then finally, we can using sigma f of ck times delta sk. K is from 1 to n, and finally we take the limit, right? We can get the value, get the area. But right now, we just apply the same idea to this part. Cross section, we have a area for this cross section times delta sk. Then finally, we just sum them together and take the limits. Finally, we can get the result. So it's just, you can just easily image the idea, extend the idea to the 3D cases. Okay? So the so-called cross section, we will say it's a region. This is a cross section. R of x, right? Why x? Because you can see different x. Different x, you would use different plane to cut, right? So when I just press my plane here, you can get this plane. When I use my plane here, if I use my plane here, you can get this plane. So different x can produce different plane. Using the different plane to cut, then you can get different cross section. So that's why we say cross section R of x with area A of x, right? Because the region is different. Of course, the corresponding area will also be different. So that's why we can have Rx is about the region, the cross section, but the size is A of x. Okay? Then, so just like the Raymond sum, we just do it for the 2D area. We just follow the same idea to get the volume for the 3D object. So if here is A, and here is S of B, S is equal to B. So we can use P is equal to X0 is equal to A, X1, X2, blah, 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 SK minus 1 SK, blah, blah, XN minus 1 SN is equal to B. So we call it partition, right? We can partition the interval from A to B, then we can have several subinterval, right? So the volume of the K slab. What is K slab? K slab means the cross section. So just like this, this is for the case pieces. Case piece. This is for case slab for a 3D object. Then it will be almost like VK is equal to A of SK times delta SK, right? AK means here, the area size, times delta SK here. This is delta SK. Then when you just time them together, then you can get VK, right? VK means the small portion, the volume for this small portion. Then finally, we can just sum them together. V is equal to limit n is approaching infinity sigma. K is from 1 to n. A of SK times delta SK, right? As the non-P is approaching 0, or we say n is approaching infinity. So we can have this. So you can see this is the small portion each small portion, then we just sum them together, and finally we just take the limit of this summation, then finally we can get its value. So finally, we can say that it will become integral from a to b, a of x times dx, right? You can simply have a mapping for this part to map here, a of s can map here, and delta s can map to dx, right? So the problem for us is how to formulate a of x. The problem normally is this. How can we just formulate a of x? Because just like I said earlier, for each part, is a of x is different. So we must follow some rule to formulate a of x. So later on, I will show you disk measure, washer measure, and then they also follow the same concept. So the idea is also very important, is for each stamp, you just need to know how to calculate its area. Then just take the integral of it from a to b, the interval. Okay? So how can we do that? Calculating the volume of a solid. The solid is I just mentioned this, a 3D object. Okay, so how can we calculate the volume of a solid? The first thing is, please just sketch the solid and a typical cross section. So as I mentioned earlier, it should be a of x, right? Because different x, we can have different cross section, right? This is the first part. The second part is find a formula for this a of x. Then find the limits of integration. So normally it will be done by from a to b for some interval, for the interval from a to b. So we have to limit a and b for this integration. Then finally, just integrate it. Okay, so I will give you a typical example just like this. This is talking about a tube, a can. It should be a can. Okay, it's a can. Then actually there is some description, but I just simplified it by using the figure to show you what we were asked to calculate. So it's a tube, and then you just use the plane, slanted plane, to cut it. So after you cut it, you can see there is a cutting plane here. Okay, here. If we assume it's x, right? And then if This direction is y. So after we cut it, you can see the intersection will be here. Oh. Yes. Sorry, maybe my. Okay. There is also a circle here. After we cut it, right? And then finally we can get this one. The green part, the origin part is the value they just access to do. So I can show you the idea is just like this. This is a can.
Yeah.
Then I use it's that. Okay. So the idea is just use this and then use this for 45 degree to cut it. Then we can get this part. So the question, actually there are some descriptions for this problem, but I just simplified it. I just directly show you the figure. Finally, they just access to calculate this value, or the origin part I show you here. So this part they just request us to do. Okay. Because the cutting plane just passing the core of the can, so you can just try your best to image that the volume I show you here. Okay, so that for S, we need to know for different X. For example, here is different X, right? Different X is here because this is X-axis, right? This is Y-axis. When we just use a plane to cut, we can get, maybe I use different color. Different X here. We use different X to cut, then we can get this one. For example, if I just cut here, I will get a none, only a none. But gradually, when I increase X, I can always get the cross section. And finally, if I just cut it at this point, I just cut a line, vertical line here. Here is a horizontal line, here is a vertical line. But in between, we have several, what is this shape? Rectangle. We have many rectangles in between 0 to, for example, if this is 3 or 8. Okay? 好，这个我稍微稍微更大一点。这是一个什么问题呢？这个问题是我们还要用那个截面积的方式来算这个题目，就从截面来算这个题目。那这怎么做呢？它问题是什么呢？就是用一个罐，那刚我说明就是用一个斜平面45度角去截它。那截它的同时会经过这个它的正中心点。好，那截出来的时候会有这个图形，这个图形我不知道叫什么名字啊，没有特别的名字，它只是一个 can， 然后用截平面截它，然后跟这个黄色这平面所接触的体积是长不一样。那现在我们的问题就是说，我说要算这个体积怎么办，对不对？刚刚有讲了 ，cross section 会落在你 x 不同地方，你截出来的面积就会不一样，对不对？所以最极端的情况就是我 cut 在这里了，然后就只会指向这条线了。其实一条线也算是一个矩形，对不对？只是它的高度是0。 一点点的时候 cut 的时候开始就有一些形状了。它 cut 出来之后，它会是个长方形。想一想，一开始你会觉得怪怪的，但想一想它确实是一个长方形。你这样想就好了哈。你如果中午吃饭的时候没事想一下，我们怎么看？我们是这样像劈柴一样这样被劈下去。Our cutting plane this way, right? When we cut, you can just find it's a rectangle. Cut it, rectangle. Cut it, rectangle. So no wonder it should look like a rectangle. So if we want to calculate the area for this rectangle, what we need? What we need to prepare? We need to prepare the width and height, right? Width and height. If we can get the width, then we can get the height. Times them together, then we can get the area of the rectangle. Okay? So when I just show you the figure, we can say we just finished the first part. Then the problem for us is how can we just get the a of x? How to get? This is our second part. So if I want to get the a of x, different area. I just divide it into two parts, two perspectives. The first perspective is here is x, and the cutting plane is here. So if here is x, because the degree is 45 degrees, so that means this is 45 degrees. So I just ask you to see this solid from this angle. So you can see this is cutting plane, this is the plane, and then we can get we try to get the height. Right? So height here, if this is x, since it is 45 degrees, so here the height should be x. If x is here, then this is from this angle. If your eyes here, and then you can get this one. Then you can get this one. But if your eye is on the top of, if your eye is here, and you see that, then you can get. Because you're just on the top of here, you just see this, you will see a circle. You will see a circle. So that you can get a circle. Right? If your eye is here, you can see a circle. Then if this is x, this should be x, right? And your cutting plane will reproduce if this is y. This is 0. If your x is here, then you can get your cutting plane is, you can get this one. This is the width. Right? When you just pretend you just stand on the top of the plane, when you just look at this shape, you can get a circle. So if you can get the width, then we can get this part, right? If we can get this, we can get this part. Okay? So if this is x, this is x, and because it's a circle, right? So based on the problem, actually it's a circle with a radius is 3. That means here is 3. So if you want to get a width, it will be square root of 9 minus s squared and times 2. Why times 2? Why times 2? Because if your x is here, your value will be square root of 9 minus s squared. But you should double it. You should double. Here is one part, here is the other part. Then finally the width should be this one. So with this, with this and with this, your a of x, we can get a of x is equal to x times 2 square root of 9 minus s squared. You just direct times these two factors together, right? One is height, one is width, then you can get the area. Now you already know how to get the area for this part when x is equal to x. Then you already know this part, then just try to sum them together. So the third part is the rectangle will runs from s equal to 0 to s equal to 3. So the next thing we need to do is we can get the value from 0 to 3, x times 2 times 9 minus s squared, square root of 9 minus s squared dx. And finally, you can find the result is 18. You can just use the substitution to substitute this part and then you can get it. For the calculation part, you can just simply apply the substitution rule. But the most important part is here. I want to emphasize this here. This shape, and also when you just use plane to cut here, you just image that you use a plane to cut this value, you can get this one, right? So we need to know how to calculate this area for this rectangle. If we want to calculate the area of a rectangle, we need to know its width and its height, right? So how can we get the width and height? Two perspectives. One is from this perspective. You can get this. When x is here, when you cut, your height should be x. Your height should be x, right? When you just place your eyes here on the top of this tube, this can, you will see a circle, right? And the cutting part is here. Then you need to calculate the width, right? The width will be related to the value here. Then this is when your x is x here, then your height should be square root of 9 minus s squared. Then two parts. Here is 1, here is 1, so there is 2. Then you just for each rectangle, you can just get this one. The next part is we need to measure the range, the limit from x is equal to 0 to x is equal to 3. Then just try to calculate the integral of this. For calculation, I think it shouldn't be a problem for you, but the most important thing is how can you just measure the cross-section, the area of the cross-section. That's the most important. So sometimes this part is the hardest one. This part is the hardest one. You need to find a formula for ALX. Just like this. This part is the hardest one. Okay, so this is the concept of using cross-section to calculate the volume. 这部分有没有问题？有点难理解哈。如果第一次看可能有点难理解，不过就是可能要想象一下那个图形跟那个斜截面去切它的时候，切出来的那个立方体长这个样。那这个样，当你用一个平面正切它的时候，切出来的时候，因为每一个正切都切出一个矩形。好，我刚刚有拿罐子的，你回去可以拿一个罐子想一想，这样切下去就切出这一片是一个矩形。拿一个想象一个罐子分分的切了，对不对？回去有个圆罐子，你看你这样切下去的时候，是不是一个矩形在那里？知道我在讲什么？Just image that if you use this and then you cut it, use a pen to cut, then you can get this is a rectangle, just like this. So the problem will be reduced to calculate the area of the rectangle. So we need two factors. One is width, one is height. So we just divide it into two parts. How can we get the height? When your x is at some certain point, x, right? If this is x, because this is 45 degrees, so of course this is also x. Because at 40 degrees, x, right? So it should be x. And as if your point is at x, then your width is double of the height, right? This height, and height is the square root of 9 minus s squared times 2. So finally, you just calculate this one. Okay. So maybe I need to erase this part because this part just try to impress the idea of the cut. The cut cross section is a rectangle. Then I will teach you the first technique we learn, solids of revolution. 旋转表面、旋转体积哈，这非常重要哈。在 the first method we learn is the disk method. So the solid generated by rotating a plane region about an axis in its plane is called a solid of revolution. Why is that? Maybe I directly use an example to show you. For example, I give you a plane region. What is plane region? For example, I give you this one. This is y is equal to x squared. This is the plane region, 平面区域。I just rotate it. So if the rotating axis is x, then I rotate it. Then you can see we can get the volume will look like this is x, this is y, this is z. And you can see the shape will be. If you rotate it, you can get this solid, right? So try to image it. If you just use this, rotate it, and you can get it solid. So if I give you this, and give you the rotating axis, then how is the volume of this solid? This is a so-called solid of resolution. 我会给你一个平面上面的曲线，这曲面跟这个 x 形成的一个平面区域，随着旋转轴绕一圈之后，它所得到的旋转体积。那这题目的目的是要算这个体积多大。那这个题目就会有两个很重要的问题。There are two very important factors. The first one is what is the curve function? What is the rotating axis? Right? If I say axis to rotate following y-axis, the shape will be different from this one. Right? So this is the simplest one. Okay, so you already know the concept that we try to use the cross-section idea to get the value, right? We still can follow this idea. For each cross-section, can we just know the area and then just sum them together? We can get the whole value, right? So for this case, if x is here, the region x, as I told you, this is the plane region, right? Yeah, I just rotate it. So I just focus on some special point x, right? So the region here, we will just use this to rotate, right? Yeah. Then finally, you can image that here is x, you can get this one. So can you tell me what is the shape? What does the shape look like? It will be a circle, right? Yeah. It will be a circle. So here is a circle, here is a circle, here is a circle, here is a circle, until the end is also a circle. And so the so-called circle, sometimes we can regard it as a disk. It's a circle and also a disk, right? So that's why we say the disk method. We just sum all of the disks together. So how can we get the region? If R of x, if we want to get the size, sorry, you want to get the size, if R, this is R of x, right? Then the size will be R of x squared times pi, right? Because for this one, this radius will produce this circle, right? So it will be pi R of x squared. Then for each part, we just sum them together. So you can see if here is 0 to 4, here also should be s is equal to x to 4, right? So this disk, this is also disk. Then the volume will be integral 0 to 4, then pi r of x squared, then dx, right? If we take this example here, this is r of x, right? Then if we take this, if we just get the rx is it we can get this one, then we can see we just replace this part to get pi square root of x squared x, then we can just get this one, very simple, x pi, right? Pi x, so pi x ds, then we can get, it will be, this is easy, right? And finally the result is 8 pi, right? Of course, it's just our example. Maybe the r of s should be another shape, right? Yeah. But we can just replace r of s from square root of x to other blah blah blah. You can always compare the one. Okay, so what you need to remember is this one. So following this, as I told you, if the rotating axis is different, for example, we can still follow the same idea. I just extend the idea. The original one is just like this, right? And it also, its shape is here. This is y is equal to square root of x, right? Then this time, I hope the rotation axis is this way. This time, I just use the region to rotate following y-axis. What's the shape? The shape will be different, right? Will differ from this one. It will become something like right? So if the original here is 0 to 4, here is 0 to 4, y will be from 0 to 2, right? And don't forget, y is equal to square root of x. We can just change it, become s is equal to y squared, right? So again, we can get the value here. We can just use a this method to get v is integral from 0 to 2. This part, because this time our rotation axis is y-axis instead of this one is for x-axis, right? So we can get this shape. But this time we just use this one, y as a rotation axis. So we should see the shape from this angle, from this viewpoint. Then it will be pi This time it should be R of y as a rectangle, right? Not R of x, right? Because we just use this as R of y, right? And then we can get the disk for y, right? Then dy, right?
Yes.
So it will become integral from 0 to 4 pi. This is y squared, so it will be squared of square dy. So it will be integral pi y to the power 4 dy, so that the result will be this. So you can have a simple comparison in between this one and this one. Because the rotation axis is different, the result also different. So remember, when you just review the problem statement, you need to focus on what's the function of the curve, and what is the rotating axis. Because for example, the rotating axis, the shape will be this one. But if we just follow the same shape, but with a different rotating axis, the result will be totally different, and also the volume or size also different. Okay, so we just stop here for a while and then come back 10 minutes later. Okay, I can try to put them together. You can have a simple comparison. Okay, so let's just start. No worry, I will give you more examples so that I can just impress you the whole idea. So let me just show you another example that we try to calculate the volume of sphere. So what is sphere? 一个球 right? This is sphere. Right, this is sphere. So actually, if we want to calculate the value of a sphere, we can just start by a half circle. Half circle means this is a circle. If the radius is a, it's a circle, right?
Yes.
So for the upper half, it will be y is equal to positive a squared minus s squared. This is for the upper half circle, right? The complete circle should be this one. The complete circle should be this one. But we just use the upper half circle for what? For generated sphere. How can we just generate it? For example, if here is x, we can know the radius r of x. Radius means the height, right? The height. And then we use this to rotate following x-axis. Then you can see if we just do that, we can get this is x, then we can get the disk here. right? So if you just use this to C1,
Yeah.
then you can get this one, right? So this is the first step we just finished. The second step is we try to get the A of X. A of X means this one, right? Because different X, you can have different disk, different area of the disk, right? So A of X should be pi times y square is equal to pi times ax minus x squared. So the third one is v should be, if the radius is a, so the left hand side we minus a, the right hand side is positive a, so it will be minus a to positive a of x dx. It will be this one. So that will be pi a square x minus, so finally we can get this one. For the calculation part, I think it's easy for you, but the most important part is this one. You can just take a look at its shape. For this, I just make it smaller so you can just have a whole picture. So here we want to get the value of a sphere, so we just use the plane curve, plane region of a half circle, especially upper half circle. Then use the upper free circle for each part, for each x. Each piece will contribute a disk here, just like this. So if S is here, S may be ranging from minus A to positive A. When your point is X, your radius will be R of X. R of X will follow this equation of the circle, right? Then it will contribute this circle. So we need to focus on each A of X. The A of X will be pi y squared is equal to pi A of A squared minus X squared. So after that, we already know how to calculate A of X. Then we just integrate them together from minus A to positive A. Then you can get the final result. So I remember, I'm not sure if you remember your formula. For the area of a circle with radius is A, the area will be pi A squared, right? 如果半径是 A 的话，圆面积是pi A 平方。如果球半径是 A 的话，它的体积会是4/3 pi A 3次方。这我不知道你们以前有没有背过。那到这里我们就把它把它证明了啦，对不对？4/3的 pi R 3次方了，好 ，R 现在这边是 A。Okay, so that we just move to next example. Rotation about a vertical axis. So find the value of the solid generated by revolving the region between s is equal to y squared plus 1 and s equals 3 about the line s equal to 3. So there are 3 very important factors, parameters. One is this one is this one, and then about the rotating axis. So the first thing we need to do is just draw it. Draw the plane region first. This is 1. And this is s is equal to y squared plus 1. This is a parabola. Yeah. Actually, it's a parabola. The parabola will just look like this. S is equal to 1 plus 1. Right? Yeah. And then s is equal to 3. This is s is equal to 3. But luckily, the rotation will follow the line. So the line is here, the same one. Then rotate. So you can see this time, the rotation axis, the rotation line is not just an x-axis or y-axis, right? We already have this one. This one, we just rotate the plane region by about the x-axis, right? Yeah. This one, y-axis, but actually not always x-axis or y-axis. We can be a vertical line or horizontal line. But in this case, it's happy. We can feel happy that because the boundary is same as the rotating line, the rotation axis. So this is the first step we just finished, right? Then the second part is we need to find the plane region, right? How to calculate the plane region. So we also need to focus on the radius, right? The radius will depend on which y, right? So your r of y should be 3 minus y squared plus 1, right? Because you want to use this as a radius to generate this. So we need to calculate the radius first. So r of 1 is equal to 3 minus this. Now we can get we can get 2 minus y squared, right? So the AY will be pi ry square. It's supposedly maybe let me see. Maybe I use origin is better because it's the same. But either way, it's fine. But it's fine. Okay, it will be pi 2 minus y squared. Then the third part is where is the start point? Where is the end point? Right? That means we need to determine the limit for the integral.
Yeah.
Right? But how can we get that?
3.
Yes, by using s is equal to 3. This time I use yellow because it's a boundary, right? And also s is equal to y squared plus 1. Then we can get 3 is equal to y squared plus 1, so that we can get y is equal to positive, negative square root of 2. So that means here is minus square root of 2. Here is positive square root of 2. Right? The first part is v is equal to pi, this one, right? Because we already know each cross section. We already know each cross section, right?
Yeah.
So that you can just simply do it by yourself. Finally, the result is okay. So for this example, the most important thing, two things. The first one is the rotation axis is the same as its boundary. The second part is you need to use this minus this to get the radius. 这个例子跟稍前面的又有几个特色上的不同啊。第一个，它的旋转轴不再是 x 轴，是 y 轴，这是第一个特色。你看它的旋转轴是 x 等于3这个轴。第二个是什么呢？它是一个旋转垂直旋转，不是水平旋转。好，这应该还算 OK。第三个是什么？你要决定它的旋转的那个 disk 那个圆盘大小的时候，是不是先决定它的半径？
对，
它的半径是由两个相差而成的。为什么？因为你旋转轴在这里，你的这个在这里，你要算出这个半径才可以算出它的少错的 disk。好，第四个特色是积分上下限，它其实没有告诉你，你要靠什么？靠自己去解这个联立方程式，得到两个方程。那最终才是把它整个 summarize 起来，变成你的积分式算出结果。哦。那大家不知道有没有想过哈？如果这个旋转轴不是刚好 s 等于3，它会变成怎样？它中间就会镂空了，对不对？如果这旋转轴不是 s 等于3，不是这橘色的 s 等于3，而是比方 s 等于5，大家想一想，它旋转出来，它就会中间漏一个空，对不对？这个例子是怎么样？你的旋转轴刚好跟你的边际线是同一个条线。那如果不是这样子的时候，它就中间会镂空了。镂空就我们等一下要教的所谓的 Washoe method。哦，再看一次哈，大家想一想，如果这个旋转轴是 about 的 9 是 x 等于3，变成 s 等于5。Just try to image that. If I just change s is equal to 3 to s is equal to 5. You can just image that. We still have s is equal to y squared plus 1, right? Still this one. But our boundary is this one. S is equal to 2, 3. But our axis is here. So if we just rotate, this one will be different from this one, right? But if we encounter, how can we do? How to solve? Yes. So we can just use the outer part minus inner part. We just apply the disk method twice, right? So the method, we call it solid of revolution. And we just learn second method. This is the washer. 洗衣机啊，大家都应该有看过洗衣机嘛，中间是镂空的，对不对？哦 Okay, so the concept is quite easy. I will give you two figures. One is the outer one. Whether this is y is equal to big Rx. The second one is y is small rs. So steer from A to B and just rotate by this axis. We just use this plane region. So the V here we can get is equal to square root integral from A to B pi big R of x squared minus pi small r of s squared dx. So you can see, actually we just use this method. This is also this method twice, right? You can just use the Rx, BRx to have this method for the first time, minus this part. This is how we will apply this method again. We can get the whole volume. Okay, let's just see an example. The region bounded by y is equal to s squared plus 1 and y is equal to minus x plus 3 is revolved about the x-axis to generate the solid. Please just find the volume of the solid. Okay, so normally you will be given the problem statement like this. You need to visualize it by yourself. 一般题目的时候就会出到这样子而已，有时候会把图附给你看的啊，但是有时候要靠你自己去画。如果像这个图形很简单，就要靠你自己画。好 ，OK， so let's just draw it first. Draw the region first. So the first one is y is equal to s squared plus 1. Y is equal to s plus 1. And the second one is y is equal to minus x plus 3. So that we can have the plane region just like this. Right? And then it just acts as to rotate by this x-axis. So after we rotate it, what's the value? What's the value? So we can just apply this method twice to get the washer method. Actually, washer method is just apply this method twice, right? So this is the first step we just finished. The second step is the outer Rx is minus x plus 3. The inner is small rx is equal to x squared plus 1. And then we should know which is the start point, which is the end point, right? How can we get these two endpoints? How can we get it? We just use y is equal to minus x, y is equal to minus x plus 3, and also y is equal to x squared plus 1. Then we can get x squared plus 1 is equal to minus x plus 3, so that we can add x squared plus x minus 2. So x is minus 2, x plus 1 is 0, so that we can get x is 2 or minus 1. Oh, minus 2. Sorry, maybe I just made some mistake. Sorry, sure. This one s anything I just made some mistake. S squared plus 1 minus x plus 3. So we just list them together. We can get x squared plus 1 is equal to minus x plus 3. So x squared plus x minus 2. So x minus 2, x plus 1. Oh, x plus 1 plus 2, and x minus 1. So that 1. So this is minus 2. This is 1. So that the v will be integral from minus 2 positive 1, then pi outer minus pi inner dx. So after some calculation, you can get the result is this one. Okay. So there are 4 steps. The first step, try to draw the picture by yourself based on the description. The second part is you need to make sure which one is outer one, which is inner one, right? Then make sure the 2 endpoints, 2 limits for the integral. So you need to just these 2 equations get an intersection. You can get it from. Then finally just put them together to get the integral and take it. Okay. So this is the section 1. Actually, section 1 includes many parts. Section 1 including cross-section, including disc method, including washer method. Okay. Let's go into section 2. But I'm afraid we cannot finish section 2 today, but I will give you a very quick idea about the shear measure. Section 2 is volumes by cylindrical shear. The shear measure 可乘法 Okay, the shear measure, the idea is just like this. Sometimes you may just get confused about the difference between shear measure and washer measure or this measure. So there are two very important rules to check it. So the shear measure is if I give you y is equal to f of x, then I also have a start point s equal to a, s equal to b. Then the rotation will follow s is equal to L. So I plan to use this plane region to rotate. They are a little bit different. In the past, I give you y is equal to f of s. The rotation is about this one.
Yeah.
So you can simply this, right?
Yeah.
But this time, the rotating axis is vertical line. Maybe you are thinking about, oh, can I just use the washer measure? Actually, no. Because you can see, if washer measure, you need to divide it into two parts. If you want to measure, okay, if you want to try to use washer measure, you need to cut it here. Into two parts. One is this part, outer, inner, right? Plus outer,
Yeah.
inner. Remember, this is not a shape. It's just a rectangle. Okay. So we have another way to solve the problem. If we remember your this is your curve is just stop here. So you need to use washer and two washers. The first one is this is outer, this is inner. The second one is this outer, this inner, twice. But we have another good way. The good way is here is s is equal to L. And here is y-axis. This x-axis. And use this one. This one. How should we do? We just divide it from A to B again. We have a partition. Right? So especially we have a small portion. We just use this to rotate. So finally, you can see the shape, it will be like this one. Because we have another part. So that we can have this shape. 这层，我拿这一条绕一圈，就得到这个壳。那洋葱嘛 ，onion is just one shade, one shade, one shade。用这个一层一层剥开来，这里贡献这一层，这里贡献这一层，每一层都会贡献一小块 V。If here is VK, VK is equal to, okay, if you just image that, we use this to get the shape, and then we just cut it and then roll it out. We can get the small one, get this one. Right? Just remember, this is a shear. This is shear. So when I just use a scissor, cut it, then roll it out, and then we get this one. It will be almost like a solid, right? And this is you can regard it as a rectangle. So for this one, it's like a cube, right? So what you need is, we need to know that here is delta x k, right? So delta sk will happen here, right? And also it's high, right? F of ck. The high here will f of ck, because we just randomly pick ck here so that we can get f of ck. Then, what's the length? It's around 2 pi times ck times L. If ck is here, minus L is here, right? It's radius. Ck minus L is the radius. So 2 pi times radius, we can get this. So finally, the Vk will be 2 pi times ck minus L times delta sk times f of ck. Understand? 这个呢，这合成法呢，我们今天可能把它介绍完，那下礼拜再直接用那个例子来跟大家介绍。合成法就是怎样？我就是每一段拿一段出来绕一圈，所以每一段绕出来一圈呢，它隐约可以差不多是一个长方体。这是一个长方体。那长方体这样子它就会有宽、高以及底的长，对不对？所以我们就约略估算出来是这个样子啊。所以 so that the V, the total V will almost like sigma. K is from N1. N is from K is from 1 to N, Vk. So as the norm of P is approaching 0, that also means N is approaching positive infinity, right? So the V will be limit N approaching 0, sigma K is from 1 to N Vk. So we can get the result is integral from A to B 2 pi ck, each x will be ck minus L times f of x dx. So you can see always there's a mapping. Here we will map to here. F of ck we will map to here. Delta sk we will map to here. So finally, what we need to memorize is this one. 2 pi x minus the axis f of x dx. So sometimes we have another way to memorize it, that v is equal to integral from a to b 2 pi shear radius. What is shear radius? Each point, the distance between the point and the rotating axis. So this is x minus L. And also shear height. How high? It is f of x, then dx. So you can see there is also mapping. 2 pi is here. Shear radius, shear height, then dx. So finally, please just memorize this one. So today we already learned four methods. One is cross-section method, then thick method, and washer method. Finally, this is shear method. But today, because I have a meeting, actually the meeting is running now, but I just give you the formula first. Next time, I will give you an example and also reviewing the concept about the shear method. Okay? So let's just stop here today. Okay?